the time response analysis, and we will have some introduction about it. So let's start with it. Up till now, we have studied about the control system and we have derived the mathematical model of the control system. So, after deriving the mathematical model, our first motive will be to analyze the performance of the system for various types of inputs. So, in the analysis of the performance of the control system, first we have to see that what will be the response of the system towards various input signals. So, after deriving the mathematical model, so after deriving the mathematical model, we will have to analyze the system performance. Okay. Now this system performance analysis, it can be done by various methods. We have various methods for it. So what we do in this performance analysis, we will study the some specifications of the system or some performance criteria that suppose we will study the system stability, the accuracy of the system, how the oscillation, how much oscillations are produced in the system. So these are the specifications which we will study for the various control systems. And suppose we are analyzing the performance of a control system. Now, in this performance analysis, we will see the accuracy, the stability, okay, the oscillations. We will study all these performance criteria. Now, how we can study it? Suppose we are having various inputs. We will apply various inputs to this control system, and for these various inputs we will study these performance criteria. Okay. So in this way we can analyze a control system. Now if we are now if we want to compare two control system, then we will apply single input. Suppose we have taken an input signal and we will apply that input signal to both the control systems. Then we will study these performance criteria, and after that we will compare the performances of the two control systems for a single input signals. So what we are doing in these various methods, we are specifying some, we are using some input test signals, and we are applying these input test signals to the control system, and the output, we are analyzing their outputs for these various inputs. Okay. So what is the basis of this analysis? In analysis and designing, in analyzing and designing the control systems, Okay, so in analyzing and designing the control systems, a basis of comparison of performance of the various control systems should be made. Now, this basis, what is this basis? This basis, it is set up by specifying particular input test signals. Okay, we will use some particular input test signals, we will specify them, and for those test signals we will compare the performance. Now this, but how then we are going to use, we will have comparing, what we will do, comparing the responses of various systems to these signals. And what we will compare? We will compare the stability, the accuracy, that is, complete evaluation of the system will be done. Okay, and after evaluating we will give the corresponding results for it. So what is time response analysis? It is again a way of analyzing the performance of the control system or comparing the performance of the control systems. Okay, so this is after deriving the mathematical model of the control system, the first step will be to analyze the performance of the systems. Okay, so let's define what is time response analysis. Why we are using the time response analysis? To analyze the system systems performance. It is one of the method of analyzing the systems performance. Okay, so nowadays time response analysis is very important. First step, it is the first major step which is done to analyze the system performance. So it is very important step after deriving the mathematical model. So let's define it. Time response analysis, it is defined as so time response analysis of a system means as to how a system behaves in accordance with time when a specified input test signal is applied. So here we are analyzing the system performance in accordance with time. That is why it is known as time response analysis. Here also we are applying a specified test signal will be applied, and we will then see that how the system is behaving in response to this input test signals. Okay, so this is time response analysis of a system. Now this time response analysis of a control system, it has two parts. Okay, the first part is called the transient response, and the second part is called the steady state response. So we can say that the complete time response of a system will be divided into two parts: transient plus steady state. Okay, so let's see that what is the transient response and what is the steady state response of a system. First, we will start with transient response. Now, any control system, it will be having energy storing elements in it. Energy storing elements like inductors, capacitors, and mass, and they will be the control system, it will be made up of all these energy storing elements. Now if these energy storing elements, as they are part of the control system, so we cannot avoid it, and in a control system we have all these parts, that is all these energy storing elements. So the energy of the complete system, it is distributed. Okay, so it takes some time for a system to change from one state to another state, and this time taken by the system to change the states is called the transient response. Okay, so we can define the transient response as, it is defined as that part of the response that goes from the initial state to the final state. Suppose that when we have the system, this is the system, and the first state of the system we call it as the initial state. Okay, now as we have applied an input to the system, this is our system, we are applying an input to it. So this is called the initial state of the system. Now as we applied the input, it will give some output to us. Okay, so time has started from the initial state and it will go up to the when the system has attained its final state. So it is that response of the system which is going from the initial state to the final state. Okay, also we can define it as the time required to change from one state is known as transient time. That is the time taken for the system to change from one state to another state, and the values of the variables, the values of the variables during this time is called transient response. Okay, so these are the two definitions of transient response. First is that it is that part of the response that goes from the initial state to the final state, and second, it is the time required to change one state to another state. We will call it a transient time, and the value of the variables which is changing in between this period is called the transient response of the system. Okay, now let's define the steady state response. Steady state response, it is defined as a state with fixed response when time reaches infinity. When we have give this system, we have applied an input to it and we are getting the output. In between these two states, the system is changing, that is, the variables are changing in between it. So that part is the transient. Now, when the system, it has attained the output, it has attained the variable, and after the time is changing, but the state of the output or the state of the system is not changing, it means it has obtained a steady state. Steady state means a state which is not changing with time. So when the system has attained a steady state and it is not changing, that is, the response is fixed. So that response of the system is called the steady state response. And this steady state response is achieved as the time reaches infinity. Okay, so if we make a graph for the response of a system, okay, so here we are having the reference line. Okay, this is our output and this is the variables they are changing, or the output of the system for a input is changing. Okay, so when the system is changing its output from the initial state to the final state, that is called the transient response. Now here you can see that after this point, the system has attained a steady state. That is, after that, the output is not changing, it is fixed. So the response is fixed of the system. So after this point, the response is called the steady state response. And what we have plot here, we have plot the output of the control system in response to the time. So this is the response of the system with respect to time, and we have applied an input signal to it. So this is the complete time response, and it is divided into two parts, that is the transient response and the steady state response. So these were the definitions of the two types of time response. Now let's see some differences between it. Okay, the first difference between the transient response and steady state response is that the duration, that is the transient response is from the initial state to the final state, whereas the steady state response is from the state which has achieved a fixed response to the infinite time. Okay, so the first difference will be the time of response up to 3t or 4t. What is this 3t and 4t? T is the time constant. Okay, T is the time constant of the system. So this is 3 times of the time constant or 4 times of the time constant. We are multiplying 3 and 4 to it. So up till that time, the response which we are getting is called the transient response. That means it goes to 0 as time becomes large. Now the steady state response, what it is? The time of response after this 3t or 4t, that will be steady state response. T is here also the time constant. So it is called the steady state that is it is the response which remains fixed after transient time has end up. Okay, we have seen in the figure that the transient response, it is starting from the initial state, that is from 0. So it is the time that goes to that starts from 0, starts from the initial state, and it goes up to the final state or the steady state, that is the state where the system has achieved a fixed or the fixed response. Okay, and a steady state is the time response after 14. Now second difference between the transient and steady state is that it does not depend on the input signal. That is, whatever be the input signal, the transient response will remain be the same. But steady state response, it depends upon the input signal. The third difference is that the transient response, it reveals the nature of the system, that how much the system is oscillatory, how much oscillations are produced, whether it is stable or not, accurate or not. That is, we will get that what will be the nature of the system. So it reveals the nature of response of the system. And what is it will reveal, that is either it is oscillatory or it is over damped. Okay, and also it will give an indication about the speed of response of the system, that how much fast or slow is the response of the system. Whereas the steady state response, it does not reveal anything about the control system. It does not reveal the nature, but it reveals the accuracy of a control system, that how much it is accurate. Only this specification is given by the steady state response. So these were the differences between the transient response and the steady state response. So in this video, what we have studied, we have got an introduction about the time response analysis, why we do the analysis or the time response analysis for a system, and how it is defined, and what are the types of transient response, time response analysis, how we can divide it. We can divide it into transient response and steady state response, and then we defined both these terms, and then at the last we saw the differences between them. I hope this video is clear to you. Thank you.